Okay, real quick, we're going to go through section 5.H1 for the honors. And it shows us that we have two triangles that are congruent, because it shows us that the sides are all congruent, and explain how we have geometric tools to use them. We can use a ruler or a compass to show that the measures of these lengths are equal. Let me go grab one of these real quick and prove it to you. Okay, so I have a compass real quick. I'll show you that GY is congruent, or GR is congruent to, this is a little loose, congruent to HY. And GR or KR is congruent to YM, and GK is congruent to, slid on me, is congruent to HM. Yep. As soon as that they assume them, that means that assume that they're congruent, which means that the measures are equal, and then since the measures are equal, that use a compass. You can use a compass, or ruler, or patty paper to show the measure lengths, measures the lengths, LENGT lengths, measures are equal. Alright, so therefore the triangles are congruent by side. Alright, so there you go. So write a sequence that will map, let me move it up a little bit. Next one, write a sequence that will map HMY onto RGK. Alright, well, the first thing that we're going to have to do is reorient HMY in the same way as RGK is. Alright, so what do we got to do here, right? So we have HMY triangle. What is going to be the type of transformation that's going to have to reorient this on top, reorient the same direction as RGK? Well, will rotation do the trick? Nope. How about rotation this way do the trick? Nope. So it's going to be a reflection. Reflection is going to do the, well, it looks like it, well, how did I do that before? So that's the, that's that. And then we're going to have to, looks like we're going to have to probably reorient this, maybe one of these things, and then a rotation. Yeah, so a reflection. Let's see. Okay, let's do a reflection of some sort. Okay, and then a rotation of some way. That's going to have to be the way to do it. Okay, or how about it if I translated it? If I translated it and then I reflected it. I think that is what we're going to need to do. So I have to translate it so it sits here, because I think I want to reflect it so that 3, this is the point I'm looking at right here. I'm going to reflect it so that I want to move it so that when I reflect it across the y-axis, that this one and this one flop. Right, this one becomes 3, and the 1 stays the same across the y-axis, but 3 becomes negative, right? And then this one becomes 2, -2, and this one becomes 1 and -1, right? So the first thing I need to do is reflect it over to this way. All right, so my translation here, this guy needs to go to here, I believe. No, it needs to go needs to go to there. So this guy needs to go here. So it's going to be my 1, 2, 3, 4, 5, 6. It's going to map. So my x, my delta x is -6. My delta y is -1. Delta y is -1. Okay. And then I have to reflect it across the x-axis. So if I do that, it'll map it pretty nicely, I believe. Yeah, that's the way to do that, right? So looking for what there I was looking for was to see how looking for points that would line up nicely if I had lined it up over there. So that was a little tricky one. Okay, so there's that one, right? So the answer for this one was be a translation of negative, so left 6 units, then 1 unit down. So and then a rotation across the x-axis. Flop the x's. That's what we did. Okay. All right. So then we're going to draw y prime, h prime after the first transformation, right? So I'll just do that. So that first transformation, we kind of did it on patty paper already. That's going to put y is -6. 1, 2, 3. Sorry, x. Yeah, -6 for y is 1, 2, 3, 4, 5, 6, and then -1. This is y prime, and then so it's going to be h is 1, 2, 3, 4, 5, 6, and then down 1 is h prime, and there's going to be 1, 2, 3, 4, 5, 6, down 1 is m prime. Okay, so that is our hm, that's our prime. Okay, let's see if that is what it looked like down. Yep, that is it. Okay, all right, so that one's done. Okay, then map the vertices HM onto HMY. And then map the vertices onto, okay, then we just have to reflect it. Okay, so map the vertices, that's what we did. Oh, we gotta map the vertices, all right, so now we gotta just draw the, mapping the vertices is drawing the dots. What's going to R here? Okay, yeah, so that's mapping the vertices, and then we got to reflect it. So we'll reflect it onto itself here. When we reflect it onto itself, we'll make that blue. Reflecting it onto itself, we'll make this H gets reflected onto H prime. This will be H double prime, I guess. And then this will get reflected onto G. Y will get reflected onto, and then K will get reflected onto, M will get reflected onto, so it'll look like that. It's after the reflection. Oh, this isn't the right one. This should be like this. In a rush get this done before the period ends. So we get the red lines plotting from here to here, and the blue lines plotting the flipping. So this blue line needs to plot from here to here. There we go. Yep, so the blue lines are plotting the reflecting, and the red lines are plotting the translation. There we go. I think that's clear enough. Okay, there we go. Let me label this one H, Y, M, also known as K, R, G. All right. So now we're moving on to the next one. And it says that the outcome will map HYM. How do we do this? HYM mapped onto HYM mapped onto R HK mapped onto RGK. I mean RGK. Because point H corresponded with G. No, point H corresponded with R. The point R. Point R, or point H corresponded with, yep, point R, H, point R corresponded with, wait a minute. This stuff confuses me at times. I just wrote all this stuff down. Let me take a look. All right, so H and R, that's right. H and R corresponded with each other. R corresponded with H. Wait a minute. N corresponded with, there's another error in the book. N, there is no N. Okay, so R corresponded with, all right, so HMY, yep, corresponded with, this should be probably be M. M corresponded with K, and that means that this is wrong, and this should be Y. Y corresponded with G. Man, I love when the books are wrong, huh? Okay, all right, so because of the definition of congruence, in terms of rigid motions preserves line distance, preserves distance. It can be stated that triangle HYM is congruent to triangle RGK. Since it was assumed that all these triangles were congruent, then SSS is sufficient, side is sufficient to show that the triangles are congruent. All right, so that's what all that stuff is talking about. All right, so select everything that is true about these. All right, so if I have these triangles here, let me go ahead and grab a, yeah, sure, I got this, I can do this like this. All right, so we have GR, my GR side, so I have GR is congruent to RK, this is R, this is K, this is R, and GRK GRK is congruent. All right, so that's side, angle, side. Okay, so that means that one is good to go. Okay, GR is congruent to HY. Okay, KG is congruent to, and then GRK, so that does not meet. That's no good. Okay, it's not the right sequence. KG, which this one should be 3. And we'll go 1, 2, 3. We'll go 1. I'll just do this. I'll go like this. I'm gonna go. This is G. Nope. This is. Yeah, that was right. This is G. R. K. And this is. H, Y, M. Let's do it a little easier like this. We said that, well, we already proved. We have two triangles. We have R, G, K is congruent to triangle H, Y, M. Wait, that's what we said up here. Okay, so we have GR. Let's just do this. Mark this up like this. Okay, so we're marked up like that. All right, so we have GR, or RG, that's a single line. HY is a single line. RK, RK is a double line. HM is a double line. And GRK is the double angle, the triple angle. Triple angle. YHM is the triple angle. And it goes, alright, so it's the side and then the angle between the two sides. So 1, 2, 3. Check. That's good. Alright, so then we have GR. That's the single. Or do we have GR everywhere? GR, HY. RKHM, 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 RKHM. The other one is the triple. And then this is the triple. RGK is a triple. RGK, MYH. MYH is a double. That's not gonna work. Nope. RGK, MYH, that's not gonna work. No. And then that one's not gonna work. Nope, because it breaks the pattern. All right, so I think this is double. This is 3, 2, 3. So this is gonna be side. So this is the triple. Oh, wait a minute. Oh, that's double. I didn't double check this one. This one is the double. There's a single, triple. So this is the single, the triple, and the triple. That's not side, angle, side. Nope. That's angle, angle, side. Or that's side, side, angle. It was not a thing. And then we have the KG, triple, the double, and then, oh, that's RKG. RKG. That's the single. RKG. That's side angle side. That one works good. Okay. Okay. So then we have the side angle side, and then you repeat that process for the next one. And if you repeat that process for the next one, you'll get this one here. This one here, and this one here. Okay, hopefully that helps out. I'm running out of time, so I wanted to get another one in before the next one. Hope you guys have a great time. Hope that helped out.